Hello, everyone, and welcome to today's webcast on Delta Lake, specifically boosting your data lake reliability and performance with the assistance of Delta Lake. I'll introduce myself before we get to the content. My name is Robbie Shaw. I'm a Thorogood Consultant based in our London office, although obviously working from home at the minute. Part of our UK Databricks capability team, and I've implemented Delta Lake in a number of projects for organizations in the insurance and CPG industries. These contact details will be up again at the end should you want to get in contact about the content that I present today. The agenda for the next half hour or so is first a quick overview of Thorogood, then we'll dig into the Delta Lake content, starting with an explanation of what Delta Lake actually is. Once we have that covered off, I will go on to discuss the key features and advantages of Delta Lake, with the addition of a few demos to back up what I cover in the slides. The demos will use a combination of a Databricks workspace and an AWS environment. And then once I'm done with those, I will also cover some disadvantages of Delta Lake that are also really important to be aware of. Finally, I'll round off the session with some advice on how you can get started with Delta Lake. For those of you not familiar with us, Thorogood is an independent business intelligence and analytics consultancy with operations in the UK, the US, India, Brazil, and Singapore. Our core business is the design and development of business intelligence and analytics applications, but we also provide a full range of services, including strategies, roadmaps, training user adoption, and support and data services. We keep customers at the core of our business, and we do this by putting our clients first and maintaining the focus on their business in everything we do, and then unlocking the business possibilities by combining that customer focus and knowledge of their business goals with the most modern cutting-edge technologies. Through this, we can unlock analytic opportunities and drive real business value. We stay in the forefront of technical possibilities through our partnerships with the companies that are providing world-leading business intelligence and analytics tools. Delta Lake technically falls under Databricks' partnership, but it's also highly relevant to our partnerships with cloud providers AWS and Microsoft. The first obvious question to cover is, what is Delta Lake? Well, if you Google Delta Lake, two things come up. One is an open source storage layer created by Databricks. The other one is a picturesque lake in Grand Teton National Park in Wyoming. But only one of these is going to improve your organization's data engineering processes. Unfortunately, data engineering improvements can't be found via hikes in national parks. However, the storage layer is pretty good in its own right. At the top of the Delta Lake website, there's this definition. Delta Lake is an open source storage layer that brings ACID transactions to Apache Spark and big data workloads. And to translate that to slightly simpler language, it's a cloud storage layer. Data is stored as essentially version compressed Parquet files, plus an accompanying Delta Lake transaction log, which is also sometimes named the Delta log. Version files means that multiple old versions of the same file are stored in addition to the most current version. Therefore, to tie all this together, when you call the latest version of the data, the Delta log steps in and provides the latest file version with all the latest transactions applied. It can exist on top of cloud data storage, for example, Azure Data Lake Storage or Amazon S3. It can also exist on top of HDFS. And then the features of Delta Lake provide greater reliability and performance to your existing data architecture. These features will be covered in greater detail in a few minutes. To give a little bit of background into how Delta Lake has grown in the past couple of years, in its first instance, Delta Lake was called Databricks, and was a service available was called Databricks Delta and was only available through Databricks. This is still the common way, and that's how we'll be demoing the tool today. Then at the 2019 Spark AI Summit in San Francisco, Databricks announced they would be open sourcing Delta Lake. And then the same year, the European version of the same summit in Amsterdam, Databricks announced they were donating Delta Lake to the Linux Foundation with an open governance model. Okay, so we've covered what it is. Let's get on to why it's useful. Delta Lake offers an array of advantages which stem from 10 key features, and these features cause the following advantages. Multiple users can work in concurrency without disruption. This is because every operation on a Delta dataset is recorded sequentially in the Delta Lake transaction log, and then carried out sequentially on the most recent version of the file. The storage format of Delta is Parquet. There are performance benefits with this format, and it is relatively common. Therefore, it increases the likelihood of compatibility with other tools in your organization's data platform. Two of the key features are Schema Enforcement and Schema Evolution, which allow for strong schema control over new data loads. There are some commands which can be performed on Delta tables, but not on regular tables, and there is a demo of that coming up. A Delta table supports both batch and streaming options. It is very easy to review changes made to the data in a feature called Audit History, and one can reference older versions of data using a feature quite fancifully named Time Travel. All of these advantages, complemented by the main feature of ACID transactions, will bring more reliability and higher performance to your data lake. So these are the high-level advantages covered off. Let's drill down into the key features. So there's 10 key features that I will cover. I'll cover some in more depth than others because they do vary in complexity and importance. First up is ACID transactions. So ACID is an acronym for atomicity, consistency, isolation, and durability. Delta Lake transactions meet all 4 of these criteria. First of all, atomicity. Every Delta Lake transaction succeeds completely or fails, which prevents partial changes. This means you won't get caught out if a transaction fails partway through and only some of the transaction steps have been applied. You will easily be able to tell if the transaction was completed because it's essentially all or nothing. Consistency ensures the data post-transaction will adhere to all defined rules, otherwise the transaction will not take place. This gives you security that a transaction won't run if the end result won't meet your set rules, and this ties in with schema control. Isolation. Concurrent transactions affect the data as if each transaction had been run sequentially in isolation. Delta Lake uses optimistic concurrency control, where the transactions are performed sequentially with the assumption that the first transaction doesn't prevent the second transaction from completing. If it does prevent the second transaction from completing, then naturally an error will be thrown up on the second transaction. And finally, durability, which guarantees that the transaction is committed. For example, it should be even in the event of a power failure. The main driver behind ACID transactions is the aforementioned Delta log, which acts as a single source of truth regarding recording every change that has been made to a table. If a user makes a change to a table, that change is split into its common components, and then once the change is fully complete, that set of steps are added to the transaction log as a JSON file. This is what creates the atomicity because the change is either recorded in the transaction log and applied anytime someone reads the table, or it isn't recorded at all and then isn't applied to the table at any point in the future. Second up is updates and deletes. Some common commands cannot be performed on traditional data lake tables in Databricks. However, they can be performed on Delta Lake tables. This improves efficiency quite a lot. So if you take, for example, we want to just do a simple delete from, looking at this slide, in command 5, we have delete from clean taxes where the state is California. And you can see that an error has been thrown up saying the delete only supports Delta sources. Okay, so let's grab a Delta table that we have. So we have loan by state Delta. And again, we will delete where the state is California. And you can see that ran smoothly, no problem, with one Spark job. Therefore, if we're not going to use Delta in Databricks, we're stuck with sort of multi-step processes to compensate for when these commands aren't possible. So if you look on the right, if you want to use Spark SQL to delete data from your traditional data lake, you'll need to select all of the data, not including the rows that you want to delete, then create a new table from that query, that select query, then delete the original table, so delete clean taxes, and create a new table called clean taxes 1. But then you need to update clean taxes 1 to be called clean taxes so that any downstream dependencies are still working on the correct table. I had a demo for that in Databricks. So what I have here is I'm in an AWS environment, and I'm in an Amazon S3 bucket called TGBIA, and I've created a folder called Delta Lake for these sets of demos. And essentially, I've got subfolders called bronze, silver, and gold, and they're essentially meant to replicate a data architecture where you're transforming your data to keep improving it so that by the time it moves from bronze all the way through silver and then to gold, once it's in gold, it's fully ready to be reported off. It's completely cleansed and in the best format possible. And within the bronze table, I have a couple of CSV files that I've loaded from probably an on-premise source. And what I've done is I've loaded in this CSV file called EPL Players Dataset. I'll explain what the dataset looks like in a second. But I've essentially loaded that CSV file from an AWS S3 bucket into a data frame. I'll not show these steps. I've hidden them just because I don't think they're that important in showing Delta Lake's features. They're sort of just admin steps to get the tables in the right place. Then I can save the data frame as a table. So I now have a data frame and a table. And then I create a Delta table using the table I just made as its source. So therefore, I'm left with a traditional table called EPL not Delta and a Delta table called EPL Delta. And then I've displayed the first 10 rows of the original data set to show you what the data looks like. And it's essentially Premier League footballer data from a few years back. And it's got ID, it's got their name, it's got a made-up email address, phone number, their company/club, their position that I've renamed job title, and a couple of metrics. And it's sort of meant to replicate like GDPR data. And first of all, we'll go to the delete example. So you can see here my notebook. So I had my cluster, it's attached to a cluster. I'm not going to run any of the code live, so it doesn't need to be running, so I'm saving some costs there. And it's a Python notebook. And I did some Python commands earlier, but now I want to use the SQL command. So I've used the magic SQL line of code to transition to SQL language. And I want to do a delete from my non-Delta table where the job title is equal to goalkeeper. And I've tried to do that, and I knew it wouldn't work because it's told me the delete only supports Delta sources. Okay, so we have the exact same table in Delta. Let's try it in that. And as you can see, the exact same piece of code, and it's run perfectly with 4 Spark jobs. Again, it's the exact same story with an update. So we want to update our non-Delta table. We've noticed in both data sets that the job title for defenders is spelled incorrectly, and we want to just fix that. So we're setting job title for any row where job title is equal to defender spelled incorrectly. And similar to last time, it told us that update's only going to work on a Delta source. And as you might expect, it's functioned as correctly as soon as we've done the exact same piece of code on our Delta table. So additionally, we've had our data set. We've been sort of using it for reporting, and we've realized that our appearances values are wrong. So if you remember, that was the one of the metrics we had, and it's wrong for anyone where the company's Chelsea. Additionally, we've also noticed that someone from the same company with surname Pulisic was missing completely out of the data, and we want to correct that. So the correct version of the data has been loaded up here, again into our bronze table, into our bronze layer, and we have then created, loaded in that CSV file, and out of it we've created 2 exact same versions of the data correction data set, one called data correction not Delta, obviously the traditional data lake table, and then the exact same but as a Delta table. And then just to see what that data set looks like, it's exactly the same, except we now have the correct appearances here. You can see it was only for the company Chelsea, and also the top row is the one that was missing completely from any of the data. So we have our old data set where we know that anyone with the company Chelsea is wrong, but we want to fix that with our new correction, with our new corrected data set, our corrected tables. So using the non-Delta tables, let's see if that's possible using a merge statement. So what we want to do is merge into our original data set, EPL, our data correction data set, anywhere where the IDs match. And when they match, I want them to update the EPL appearances value with the data correction appearances value. And then if they're not matched, that means they don't exist in the original data set. But I do want them included, so I want to insert them into my EPL table. And as you may expect by now, the merge statement only works on Delta sources. And again, I've run exactly the same bit of code, but only on Delta tables, but using the Delta tables instead, the Delta versions of the exact same data that was up here, and it's run perfectly with 5 Spark jobs. In the next section, we'll cover audit history and time travel together as they're quite intertwined. The previously mentioned Delta Lake transaction log with version checkpoint files allow for the most glamorous features, glamorous features of Delta Lake, time travel, and audit history. With audit history, you can generate a table, as you can see on the slide there, with records of all changes made to this table with further information on each change, such as what operation they ran, which of your colleagues ran it, which time it was completed, and more. And this is excellent for sharing the transformation workload between colleagues, plus reviewing the work you put into a final table. So one example I can think of is you could review the history and then find that there's actually a more efficient way to reach the final table. And hence you can then change that and reduce processing time and cost. Then with time travel, you can read an older version of the file simply by including the version number, as you can see on the bottom left screenshot. Or alternatively, you can pick a specific time, as you can see on the bottom right screenshot here. A useful example of this is maybe you ran a model approved to play on Friday. It seemed to be performing well, but you came back on Monday and the data had changed and the model wasn't performing as well as you remembered on Friday. So you could simply use the data as it was at 5 o'clock on Friday. Other examples of this include if mistakes have been made in transformations, you can roll back to the version before. So you can roll back to older versions to correct the data, and you can also use the audit history to see who might be making the mistakes and whether it's going to be something that's repeatable and you can try to stop. And one other thing I'd like to point out is that to replicate this capability takes a lot of code, which we previously had to do before Delta. But right now, with the assistance of Delta, it's all incredibly smooth and very easy to write. I'll now demo the 2 features of audit history and time travel in Databricks. So again, just to remind you, I've got my EPL not-Delta table and my EPL Delta table. I've just described the detail of both in SQL, and you can see the location here is in the Databricks file systems. That's within the Hive storage within Databricks. Whereas the EPL data is stored in my TGBIA bucket in AWS, which is mounted to Databricks. And as I said, audit history was a really useful tool. When I try to describe the history on my non-Delta table, as you may expect by now, the described history is only supported for Delta tables. Okay, let's try it on our Delta table. Here we go. It seems to have worked perfectly. And as you can see, I've created the table that I was showing in the first notebook, where we had the delete, update, and merge. And you can see that it was me that created it, what time I created it at, so I created it earlier today. Then I deleted any rows where the job title was goalkeeper. Then I updated the defender job title, and then I merged in my data correction data set. So if you go to time travel, and we'll use the record table above for reference, I want to select all of my data from my Delta table when the timestamp is 094740. So you can see that falls in between version 1 and version 2. So obviously if the version 2 transaction hasn't happened at this time, it's going to throw me version 1. And then just to check that is the case, you can see that in this data set, there is no goalkeeper. So the delete has clearly taken place. However, defender is still spelled incorrectly. So we can conclude that the update of defender hasn't taken place yet, but the deletion of goalkeeper has. Additionally, rather than doing the timestamp, as I said, you can use the version as of. So here I've wanted to count the rows in my data set where the version is 3. So 3 is our most recent version. And as you can see, there's 613 rows. Another way to write this bit of version is just in v2. So I want to count every row from my EPL data where the version is 2. And this time you can see there's 608 rows. So there's clearly 5 rows of difference there. And I'd be quite interested to see what those 5 rows are. To do that, I'm going to use this bit of code here. So I think I can identify it by just the name and the job title. So I select name and job title from my EPL data at version 3. But then I want to remove any of those entries where if they appear in version 2. So select everything in version 3 except what appears in version 2. And therefore, you can see what we have are 4 goalkeepers and the additional person called Pulisic that I added in. So this is the difference between before the merge and after the merge. So if you remember, we deleted the goalkeeper as part of our delete, but our data correction probably still has goalkeeper data in it. So it's really good to have picked up on this because we then might want to go, oh no, we don't want any goalkeeper in our data sets. So we can then do a delete from, get rid of goalkeeper. But we can also see that the person who was missed before has been added in between those 2 steps. You may be thinking, with that time travel, there's clearly a lot of other versions being stored. How is this affecting storage and performance? Surely the volumes are just increasing massively, and you're right in thinking that. But there's a simple solution to this called vacuum. It removes all recorded transactions and files, and the SQL command for it is as simple as vacuum followed by the table name. So when this runs, what it's going to do is delete transactions and versions that are older than 7 days from my loan by state delta. 7 days isn't always the case. You can change it. It's just the default. For example, here, what I've done is vacuum the same data set, but instead of deleting everything 7 days old, I'm deleting everything 336 hours old or over, or 336 hours or older. I've deleted all of that, which is essentially 2 weeks. And if you want to preview the files that are about to be deleted, so you can check there's nothing important you're deleting or vital, you can include dry run in your piece of code, and it'll show you the files that will be deleted. And then you can remove the dry run and delete them once you've fully checked them. Similarly to the last section, we'll cover 2 features together, and those are Schema Enforcement and Schema Evolution. So Schema Enforcement and Evolution are so important because alterations to our data should definitely be first flagged to us, and then we should have the options to integrate these alterations if they're intended. So first of all, Schema Enforcement in Delta Lake means that an error is thrown up if you try to add new data to a table, but the new data doesn't match the columns or data types of the original table. This screen grab shows an example of that error coming up. So I've tried to append some certain data to a Delta file that already exists, and it's told me there's a schema mismatch when trying to write to that Delta table, so it's not done it. Then, if that is your intention and the new schema is the schema you desire, you can then utilize the merge schema option. So as you can see, it's exactly the same piece of code, but I've used this dot option merge schema true. And that just one extra line of Python means that the command runs smoothly and updates the schema as you want. Again, I have a demo of this, which I'll run through quickly. So imagine now our data is coming from 2 different sources. There's one for our defenders and one for our forwards. And in this case, we'll be using Python and data frames rather than tables and SQL, just to show a bit of versatility between Databricks and Delta Lake. The forwards data frame is called df-epl forwards. The defenders data frame is called df-epl defenders. And then just to print the schema of both, you can see they're both exactly the same, defenders and forwards, except for forwards have this extra column called assist. And so whenever I first write my defenders data set, so I'm writing it to this location in my AWS data lake. And then whenever I append forwards data to that, even though the columns doesn't match up, it's gone ahead and done that without any sort of error or any sort of notification that that's happened. So if I was to return to the data later, what I'm probably going to realize is there's a lot of empty values in the assist column anywhere for any row that is a defender. If I try to do the same in Delta, so in this case, I'm doing the exact same, writing the defender's data frame to this location, except the format is Delta instead of CSV. And it's obviously letting me write it first time, it's an overwrite, but whenever I try to append forwards data to the defender's data, it's throwing this error of a schema mismatch when writing to the Delta table. And then to bring in schema evolution, I've added in the one line of code that I pointed out earlier, so merge schema equals true. And in this case, it's run perfectly fine, and it's appended my forwards data onto my defender's data. Alternatively, you can set the merge schema to automatic, so you don't always have to add this line. And that can be done using this little bit of code here. The final 4 features can be covered together in the next slide. So those are unified batch and streaming. So essentially, a Delta table can read. You can read from it. You can write to it in terms of batch, but you can also it can also act as both a source and a sink for streaming, and that's incredibly versatile for a table. Additionally, as you can imagine, with big data, the data sets get out of hand, but actually the metadata for them can get quite large in itself. And helpfully, Delta Lake will handle your metadata in exactly the same way it would handle its regular data with Spark's distributed framework, so that has optimal parallel processing. The open format is one of the features as well, so that just means that it's Parquet format, and there's distinct advantages of that, which I did cover earlier in the advantages section. And finally, it's 100% compatible with Apache Spark API. Therefore, if you already have data pipelines with Spark, it should be relatively easy to integrate Delta Lake into those pipelines. And I have a quick demo of the AWS console just to quickly show how it's writing out in that open format. So Silver was where we were doing our delete, update, merges, all of that processing. And I was writing to this location as a Delta file. And you can see actually that the file that is Delta is actually a folder, and that folder contains the Delta log with its JSON files for all the instructions of transactions to do. And then it also carries all these older versions of the data. So you can see the timestamp there on the right changing depending on the state of the data. And then if we just sample it, so you can see it's snappy Parquet, so it's compressed Parquet. And then if we want to just quickly take a peek at what is actually within the Parquet file, you can see it's a partition of our latest set of data, and you can see each row here as it appears. So there you've seen a bit of Databricks, a bit of AWS interacting with different data sets. This slide shows an example of a typical AWS cloud data architecture, highlighting how one may combine Delta Lake, Databricks, and AWS for an effective source to end user path of data. In this architecture, Databricks acts as the transformation tool, and it's performing these transactions on Delta Lake files and writing the files to Silver and Gold as they to promote them as they increase in integrity, and then by the time they've reached Gold, they're appropriate for reporting. And in case you're an Azure person rather than an AWS person, Azure handles Delta files in pretty much the same way as AWS, and a similar architecture can be developed as well. So I've been pointing out everything that's brilliant with Delta Lake, but I should point out the disadvantages quickly. So first of all, it's not CSV. So it's lacking the usual benefits of CSV, human readability and compatibility as a data source, particularly for front-end tools. However, CSV versus Parquet is a debate older than Delta Lake itself, and Parquet has its own storage and performance benefits. Plus, Databricks have helped develop connectors, which make front-end reporting a lot easier with Parquet sources. Next, as I mentioned when covering the vacuum command, but the volumes of data from multiple transactions and multiple versions of old data does significantly increase the amount of storage required, but a data lake can easily scale up to handle it. and the extra cost of that increase in storage won't break the bank. And finally, there's the usual drawbacks of a new tool. As I said, it's only been around since 2017. The main issue here is simply a lack of documentation and assistance from community sites. But the tool is improving, Databricks plus others are improving it, and the community using it is constantly growing. So we've covered an awful lot there. We can provide further assistance, so if you have any questions, and I'll put my details up at the end if you want to email me directly. We also have some next steps that you could use in order to help you get started. So to get started with Delta Lake, we can provide assistance at whatever level is appropriate to start at. So the easiest way to sample Delta Lake is through Databricks. If your company uses Databricks, great, you can trial it in that workspace. Alternatively, you can test it out in the free Databricks community version. Then if you like Delta and Databricks and want to set them up, we can help you get started quickly with our expertise and cloud capability. Next, we could work with you to identify any key use cases where Delta Lake would have the best benefit and work on proof of concepts for these use cases to sort of prove the value of them. And then we can also use our experience to improve your overall data architecture, whether that's migrating to the cloud or integrating Delta Lake into your existing on-premise or cloud architecture. I'd also advise regularly checking our website events page for new events, as we're working harder than ever to produce more online content. Additionally, we have a rich library of past webcasts on our website's perspective section that are really worth checking out. That concludes our webcast today. I appreciate you taking the time to attend, and if you do have any questions or want a discussion on anything, do get in touch. Thank you.